Hello, hello. We're going to be spending a bulk of our time in Unit 2 working with stoichiometry, the study of the relationships between our reactants and our products in a chemical reaction. So if I have so much of this substance, how much of this other substance can I make? The equation describing your reaction that we're looking at has to be balanced because we need those balance coefficients to describe the number of molecules or the amount of moles of those products and reactants that we need and what is being formed. Most of the time we're looking at those coefficients as moles, and those become our mole ratios, which we can use as a conversion factor. We're going to have to use that along with our molar mass. And that mole ratio is going to relate the amount of moles from those two chemical species in a chemical reaction. So we have this little stoichiometry roadmap here thing. And the whole idea behind stoichiometry, again, we're relating the amounts of reactants and products. So if we have substance A, we can find something out about our substance B. Notice that on these we have moles here. So stoichiometry part is that actual mole to mole conversion. We can only switch between these two different chemicals when we're in moles. So here in this first video, we're looking at some basic stoich. If we're not given moles to start, we might have to use another conversion factor, such as mass or particles. Mass to moles, we're using molar mass. Particles to moles, Avogadro number. And then if our problem asks for something other than moles, we just might have to make that conversion back out to one of those other units. So we're going to go ahead and take a look at a couple of examples. So here on number 2, we're looking for the total moles of product produced from the 3.25 grams of lithium hydroxide with excess H2SO4. That just means we have plenty of H2SO4, sulfuric acid, to react all of that lithium hydroxide. Well, every stoichiometry problem, we need a balanced chemical equation. Notice that this chemical equation here is not balanced. So go ahead and take a moment, pause the video, and balance that on your own real quick. So when balanced, we should look like so. In stoichiometry, we always need to start with that given, and we multiply our given by a conversion factor. Hopefully we remember that we need to drag and drop our units down. Then we have to figure out what we need to get to. Well, in order to do stoichiometry, in order to go from my LiOH to my moles of product here, we have to get to moles first. So you have to get to moles first to do real stoich. In figuring out what units to get to top, it's really important to realize that we can only change grams, or we can change the chemical. So we can change the unit or the chemical, but not both. So in this case, since I have to get to moles first, I'm going to change my units to moles, but it's still going to be moles of LiOH, and we just need to use our molar mass from the periodic table. We need our next conversion factor, bringing our units down again. Well, now I have moles, so I can do my actual stoichiometry part. But this problem's asking me not just for one of my products, it's asking me for moles of total product. Well, let's take a look at this. For our moles of product, we have the 2 moles of water, but we also have 1 mole of the lithium sulfate. So if we're looking for our total moles of product, this is something that we can easily do to make this a little bit shorter and quicker for us. I have 3 moles of total product, 2 of water, 1 of the lithium sulfate. We could do 2 separate dimensional analysis, find our moles of water, find our moles of lithium sulfate, and add them together, but we do not have to do that. We can just add them together to get that 3 moles because we're always going to want that quickest, most efficient problem-solving skill for AP Chemistry. So We still gotta complete this stoichiometry down here. Our coefficient for lithium hydroxide is 2, so we can see from our balanced chemical equation, every 2 moles of lithium hydroxide will produce our 3 moles of total product. Now we just need to math. We should have 3 sig figs. We have 3 sig figs in our given for that 0.204. Let's take a look at another example. So this is just some basic stoich here. So pause the video, go ahead and try this one out on your own, see how far you can get, and resume when you're ready to check your answer. So on part A, we have our 1 kilogram barium nitrate. We have to get that to grams first, so just a little metric conversion system there. Then once we have grams, we can find our moles. Once we're in moles, we're going to use that mole to mole ratio, and it is just a 1-to-1 mole ratio. That is the stoichiometry part. Even though it's just 1-to-1, you must show that on free response to get any credit. So we got to moles, we have one last step. That last step is multiplying by our molar mass, and that should give us our 660 grams of barium hydroxide. Watch your sig figs there. We only get 2 sig figs from that 1.0 kilogram. Taking a look at part B, we're looking for how many hydroxide ions are in this sample of barium hydroxide here. So this isn't actually stoichiometry because we're just taking one chemical and finding something within it. We can just take our answer from part A in order to find this. We need to go ahead and convert to moles first to get to something within our compound here. When we have our moles of compound, remember that we always have 1 unit of that compound per however many ions we have within it. So there are 2 hydroxide ions within every 1 unit of barium hydroxide. But we still have one more step. This problem didn't ask for moles of hydroxide ions, which is what we have now. It asked how many ions. So we need to use Avogadro's number. We still only get 2 sig figs in that final answer, but there you have it, some basic stoichiometry.